I'm Brooks Hanley, and I'm an application support engineer at Keysight Technologies. Here we have our brand new spectrum analyzer, the UXA, and its complementary signal generator, the UXG. So the great thing about the UXA is it has a multi-touch interface, and you can actually you can pinch and zoom the spectrum here, just like an iPhone, and it has 510 megahertz of real-time bandwidth. So right now, in spectrum mode, you can see all the way up to the full 226.5 gigahertz. And we're kind of zoomed into these pulses over here on the lower frequency spectrum using our real-time spectrum analyzer capability. So we have 510 megahertz of real-time capability. The UXG is a fast frequency switching source, so we can switch frequency and change amplitude in under 200 nanoseconds. The UXG speaks the language of electronic warfare, and what we mean by that is instead of IQ data, it uses something called a pulse descriptor word. So we describe different emitters or pulses from different radar sources in text files. So each row represents a different emitter, and you can design these different emitters in any kind of, say, Excel, or you can directly enter it into the box. But in order to set up millions of pulses, you wouldn't want to do that manually. We have our Signal Studio for multi-emitter scenario generation software that it will actually allow you to generate these pulse descriptor words automatically. And what it does is you specify how many UXGs you have, and how many emitters, what type of emitters you have, whether it's a search or a tracking radar. And also, so basically it's 1 to n emitters and 1 to n UXGs. And the software will decide how to spread those across the UXGs. It'll load balance. You can prioritize between different emitters so that there's no collisions in time. And all of that is very straightforward. Over here, we have our S-series oscilloscope running our vector signal analysis software. And so basically you can see we have a linear FM chirp signal. So frequency is on the vertical axis, time here. The parabolic phase is below, and then the time domain is here. And then we have the whole kind of 1 gigahertz spectrum of the chirp signal up in the left corner. And thank you very much. If you have any further questions, visit keysight.com.